Suppose that a coin is tossed twice. Find the probability function corresponding to the number of heads that can come up. So for us to get the probability function, we first of all need to identify the random variable. So in this case, it is all about the number of heads that can come up. So it means our random variable is x, and we can let it represent the number of heads. So from there, we are going to identify the sample points. So the first time we are told that it is tossed twice. So the first time you can toss, get ahead. The next time you also toss and get ahead. Or you can toss, you get ahead, and then you get a tail. Or you can toss, you get a tail, and then you get ahead in the next one. Or you can toss, you get a tail, and then a tail in the other one. So in all these cases, our random variable x, in this case there are two heads. So we have x as 2, here is only one, we have 1, here we have 1, and there we have none. So from there, assuming this coin is a fair one, it is not biased, then you expect that the probability of getting a head will be half, and the probability of getting a tail will also be half. So in these two tosses, every outcome excludes the other, so they are mutually exclusive. So it means that the probability of getting a head and then a head is just the probability of getting a head times the probability of getting a head. So in this case, it's half times half, that is a quarter. And also the probability of getting a head then a tail is also a quarter, and the probability of getting a tail then a head is also a quarter. Same applies to the probability of getting a tail and a tail, that is also a quarter. So now for us to get the probability function, we need to get the probability that x is assigned to a particular value of x. So we are going to list all of them. So the first case, the probability that x is 0. So when x is 0, it's just the probability that there is a t and there's a t, a tail and a tail, there is no head. So that is the same as the probability of t and t, which is just a quarter. And then the next one is the probability that x is 1. So there are two instances when x is 1. There's the probability of getting a head, then a tail, and then there's a tail and a head. So both of those can happen. So we're just going to look for the probability of getting a head, then a tail, or the probability of getting a tail, then a head. So that is just these two cases, this one or that one. So we just add them, 1/4 plus 1/4, that is half. Then the probability that there are two heads is the probability of getting a head and a head, which we found to be right here, a quarter. Okay, so that is all that we have. So we're just going to represent this in a table where we have x and then we have f of x, that is the probability function that we are looking for. So when we only have three instances, there's when x is 0, when x is 1, and when x is 2. So you're going to have 0, 1, and 2. So the probability when x is 0 is a quarter, when x is 1 is a half, and when x is 2 is also a quarter. So that is our probability function for that particular experiment.